Okay, so be sure to check out the freestyle if you want to kind of refresh your memory on all of this stuff right here. I definitely go over it there. So using the triangle at right to find sine of theta. Remember, sine is opposite over hypotenuse, so the side that is opposite is right here, and the hypotenuse is always the longest side. So I would say that sine of theta in this case would be 4 over 5, and that cosine is the same as adjacent over hypotenuse. And so adjacent is the side that's touching, so that would be a 3. And the hypotenuse is still the same as a 5. And then for this next one, tangent is opposite over adjacent. So I've already used opposite. That would be the 4. And adjacent, that would be the 3. See how I noticed I'm pulling the colors for you where it lives. Secant, remember the definition of secant is the the reciprocal of cosine. So without doing too much recalculating to find secant, I just do 5 over 3. Okay, but technically you can go through more steps to find it. Secant is hypotenuse over adjacent. Remember, we're supposed to flip these two things, the adjacent and the hypotenuse. So there you go for the basics. And don't forget, 3, 4, and 5 are your Pythagorean triples. And if you remember Pythagorean triples, great. If you don't, you might want to check out the freestyle, okay? So trigonometric functions are defined as circular functions. They must be positive and less than or equal to 90 degrees. A less restrictive way of defining trig ratios is to use angles, which can be any measure. At right is an angle in standard position. The vertex of the angle is the origin. The initial side of the angle is the positive x-axis. In the figure shown, the terminal side was formed by counterclockwise rotation, so the measure of the angle theta is positive. Clockwise rotations produce negative angles. You might want to highlight this one. If you go around in this direction, that's how you end up with a negative sign. You might also want to have some color coding for you. The initial side is the x-axis, and in measuring an angle, we kind of imagine that we start here and then we're going to end up somewhere. And where we end up, that is called your terminal side. So this is my terminal side. Now, what we're thinking about is making triangles from what remains. And that can be a little bit confusing because the triangle moves around into different quadrants. There's basically 8 different potential triangles that we could form. A triangle, this would be 1, this would be 2, this would be 3, this would be 4, this would be 5, this would be 6, this would be 7, this would be 8. So where your, actual triangle lives, that's going to be your job, is to figure it out. And if you are given an actual location, then where that side ends, a point that side goes through, then we'll have to use the Pythagorean theorem to find the length of the hypotenuse, okay, so on and so forth. Also, I'll take a brief moment and mention that this formula for radians, finding radians, is probably not the version that you saw. I went on the internet and I found some pretty graphics here. This is hopefully the one that you did see, okay? To find radians, what you need is pi divided by 180, and you multiply that by degrees, and we're going to do this. So you'll see me use this formula. Also, same formula, but in the other direction. If you want to find degrees, you take 180 divided by pi, you multiply it by radians, whatever the radians that you were given, and you'll be able to find the degrees. So that's the version that you may have seen, I'm hoping. This version, I don't know, it's just beautiful handwriting right here, so I copied it and put it down. This version and this version, these are the same. You can just see that what they did here was they divided by 2. So pi radians equals 180 because 360 divided by 2 is 180, okay? And if you want to go ahead and turn this into this, what do? Well, you divide by pi. So I'm not sure if you're copying any of this down, but I wanted to make sure that I gave it to you just in case. pause if you want to, if you need to copy something down. So the circular trig function definitions are listed for you right here, and I don't really necessarily memorize them like this. I'm not going to require that you memorize them in this fashion, but feel free, if you want to do some extra credit, you could always copy these 5 times, upload it to this assignment, and remind me in a comment that you want extra credit, and I'll give you credit for copying that down 5 times. Ooh, but add that, okay? Because it's important that you remember how to find that hypotenuse. It's the hypotenuse. If you had me, you remember that I gave you the formula as leg squared plus leg squared equals hypotenuse squared. Well, if you wanted to solve for the hypotenuse, I would have taught you, you take the square root of both sides, which leaves you with the hypotenuse being the square root, ready, of a leg squared plus a leg squared. Well, in the circular definition, the distance, any one of these triangles that you're looking at, if I make a triangle right here, this leg is exactly the distance of x. So I can just say x squared, and this leg is going to be a height of y. Do you see? It's a height of y. So I can just say y squared, and I have solved for this unknown distance right here, which is my radius. That's my radius, okay? Which would be, I guess, here I should put this in green, my hypotenuse, okay? So now we're going to move on and actually try to find some of these values for a particular point. And I like this this example, but it's not calculus, right? This is just kind of, do you remember doing this? And by the way, if you don't remember doing this, it's probably okay. It's not used very often in calculus. You might see a homework problem or two where I'll be like, oh, do you remember this assignment? No, this is where we did this. Okay, so find sine, cosecant, and cotangent if theta is an angle in standard position whose terminal side passes through the point of -5 and 2. Well, how do I do that? First of all, let me just draw a picture of it, okay? So I'm drawing a picture of it, and I'm saying that -5 is over here. On the x-axis, 2 is right here on the y-axis, and I would draw this triangle like this. And if this is a height of 2, and here I kind of want to have my colors here. If this is a height of 2, and this is a length from here to here is a length of -5, right? That's a better place to put these numbers, I think. Then you can see that my leg squared plus my leg squared should be 2 squared plus -5 being squared. I don't need to square -5. I know this is a distance, so I can just say 5 squared. Remember, don't worry about negatives here. We're finding absolute distances. So when you square a number, the negatives disappear. So don't even bother to write the negatives at all, because what you're going to end up with is needing to take the square root of 2 positive numbers, which are going to be 4 and 25 being added together will end up giving me the square root of 29. So that's what r is. That's the distance from here to here. And this is the length of that piece. That's r, okay? Now that I know x, I do know x, by the way. This is x, and I know y. Let's see, let's make y be green. And I know r. R is this purple. I should be able to find all of these relatively quickly. Sine of theta, cosecant of theta, something over something, something over something, cotangent of theta will also be something over something. So what are the somethings? I will refer to my handy dandy chart, and I will look for sine. R goes in the bottom here. Cosecant, R goes on top right here, because those are reciprocals, remember? And cotangent doesn't use R at all. So y is going to be green, and it goes on top, and green was 2, and green was 2. Oops, I said r. I didn't write down what r is. Here you go. It's square root of 29. And cotangent should be x over y, which would be, am I in green here? I want to be in green. x over y, y is 2, and x was red, that would be negative 5. So yay, we did those, okay? Now, this one, technically, yes, we should rationalize, but guess what? I have good news. On the AP Calculus exam, you do not need to rationalize your answers. So you may just put a box around that and let it go, okay? Circular function trig makes use of reference angles and triangles and is really not much different than right triangle trigonometry. Think of it as an extension of right triangle trig. So our 30, 60, 90 and 45, 45, 90 triangles that I taught you in Math 2 are suddenly coming to light as being very important in your calculus class, just like I told you that they would. So if you do remember where I get the reference triangle for the 30, 60, 90, great. You do not need to watch the freestyle. But if you don't remember where these numbers come from, then please refer to that video where I will tell you that this is the length of 2. If that is the length of 2, this is definitely a length of 1, and this would be the length of the square root of 3. For the 45, 45, 90 triangle, if you remember, then you're welcome to avoid watching that freestyle. But if you don't remember that a 45, 45, 90, because this is 45 and this one is also 45, forces that one to be 90. Also, that one, by the way, is 90. And this would be isosceles because of those two angles, and remembering that geometric theorem. And so if this is a length of 1 and that is a length of 1, then this is going to be the length of square root of 2. If you don't remember that, go check out the freestyle. For example 3, I need to then use these two particular triangles, okay, and figure out which one I'm using at what moment. The way that I do that is I kind of just imagine where 210 is on the coordinate plane. And so here I am. I know from here to here that was 90. From here to here that was 180. So I'm at 180 degrees. If I want to get to 210 degrees all the way around, I need to add another 30 degrees. So this is 210. And the reason that I got there was because this little piece right here I took and I added 30 degrees to that 180, which means that there's a little triangle in there. And that triangle, I'm going to blow it up. Here it is. This is my 30, this is my 90, this is my 60. And all of a sudden, I now know from this picture up here, remember that the side that is the longest side, that's your hypotenuse, that will be a length of 2. And the side that is the short leg will be a half of that, and the long leg will be the square root of 3. So we can figure out what cosine is by saying, hey, what was the definition of cosine? Well, remember it's CA, right? So I want my adjacent and my hypotenuse. So my adjacent side to the 30-degree angle will be the square root of 3, and my hypotenuse side will be a 2. So my answer to cosine of 210 is the square root of 3 over 2. But don't forget that when I'm over here in my triangle, that whatever distance out here, I am in the negative side of the x-axis. So this triangle, this distance from here to here, that's a negative distance, right? I'm in the negative part of the x-axis. So my final answer will be negative, and I don't want you to forget it. It's very important that we actually remember to put those plus signs or negative signs down. So I usually do that right at the end, but I'll try for the purposes of this video, I'm going to try and do it at the beginning from now on. So taking a look at tangent of 315, again, I want to draw my coordinate plane, and I kind of cheating. I know where I'm going to end up. This is 90. That's 90. So I'm at 180. If I go all the way over to here, this is 207. Wait, what's 90 plus 180? It's 270. So I'm still not where I want to be, right? I want to get over here to 315. And where exactly is that? It's like 270 plus 45. Yep, that's right. This angle right here is a 45-degree angle. And so that means that there is a triangle here that can be drawn. By the way, this angle is also 45, right? So that's the beauty of 45-degree angles. As I mentioned in the freestyle, I kind of already know that my answer is going to, be something related to the square root of 2. But let's see if we can figure out whether or not it actually pops up in a tangent question. Because I'm going to draw my triangle now. I'm going to blow this triangle up. You're like, what triangle? That triangle. So I'm going to blow it up, and I'm going to try and make it actually look good, like it looks like an isosceles right triangle. Here we go. That side's congruent to that side. This angle here is 45 degrees. By the way, I'll mention that this distance from here to here I know is 1, but notice how I am in the negative part of the y-axis. The x-axis is positive, but the y-axis is negative. So this is not just a 1, it's a negative 1. And then again, my hypotenuse is the square root of 2. So if I want to do tangent, remember that tangent is, it's the opposite over the adjacent. Well, opposite is right here, it's a negative 1. And adjacent is right here, it's a positive 1. So negative 1 over positive 1, which I end up with a negative 1. So 45 degrees, not always involving square root of 2, but in this case, just involving those lengths of those sides, which were 1s. Okay. Now, he refers again to his little formula right here, and that just doesn't happen to be the formula that I use, or I don't really see that formula as being useful. So I just wanted to quickly show you. Oops, I already practiced this just a little bit, so I already know what the answers are here. But let me show you how to do it, okay? So if you have pi over 2 and you want to convert this from radians to degrees, I noticed that pi is on top, so I'm just naturally going to flip pi into the denominator and put the 180 on top. Like, how did you know to do that? Well, this formula that I gave you at the beginning right here, if I'm going from radians to degrees, if I'm trying to get radians from degrees, well, then I need 180 to be on bottom. But I'm going the other way. I'm going this way. I don't have degrees. I need degrees. I need to find out what the degrees equal. So I have to use this version of it. And I knew that I wanted the pi to be in the denominator because when I'm done, I should not have any pi's in my answer. And if I put it in the denominator, then boom, they cancel out. By the way, 180 divided by 2 is 90. Let's try that again. Pi over 4, again, I want pi to be on bottom because I want it to cancel out, and 180 on top. And just in case you were wondering what 180 divided by 4 is, it is 45. And go ahead and throw that degree symbol down there because that's what we're doing, is converting from radians to degrees. So pi over 3, if you recognize the pattern, then you know that you're going to take 180 and you're going to divide it by 3, and you should get a 60. But it's not necessarily a skill that you use every day, so you might not remember. So hopefully you can remember this, pi over 3, and we're going to convert by having pi in the denominator with a 180 on top, and these cancel out, and that's how I get 180 divided by 3 is 60. Pi over 6, again, let's try this, pi over 6 and 180 over pi, and I'm going to end up with pi 180 divided by 6 is going to be 30 degrees. Converting from radians to degrees or degrees to radians without using a calculator, now we are beginning to have a real solid hand on the formula. I'm going to have 5 pi over 4 times 180 divided by pi. The pi's cancel out. Then I have 5 times 180. Divide that by 4. I'll leave that to you. I know that the answer I end up with is 225. 270. Ooh, now you should be thinking, well, wait a minute. I have 270. What am I going to multiply it by? Well, this time I don't want pi to be in the denominator because I want a pi in my answer. So I'm going to flip it, and I'm going to use the pi on top, and 270 divided by 180 simplifies out into, ready, 3 halves, and you could put the pi up here on top, or you could put the pi wherever you like, right there in the middle. I don't care. I tend to write it like this because I just think it's easier, but this way is a little bit more perfect, right? It's just a little bit more perfect. All right. So then a negative 120 degrees, again, don't forget that a negative sign means that we're going in the opposite direction around. Instead of going counterclockwise, we're going to go clockwise, and that's okay. Or did I say that wrong? In any case, you'll see me do an example of that in just a moment. So negative 120 times, ready, pi over 180. Again, I want there to be a pi in my answer. And 120 over 180 simplifies into 2 pi over 3. Don't forget to make it negative. And boom, that will be your answer. So I said that we were going to do some examples where we actually are going to draw going in the correct direction. Let me practice here. 5 pi over 6. If I wanted to draw that, do I know what that is in degrees? I don't necessarily know what it is in degrees, but I will mention this. Something over 6 I know has something to do with either 60 or 30, right? Pi over 2 I know is something about 90 degrees. Pi over 4 is something about 45 degrees, because that's double the division. Instead of dividing by 2, right, I'm dividing by 4. So anyway, I just have those memorized. So to draw angles in standard position, let's make the reference triangles to find the following without using a calculator. So tangent of 5 pi over 6. Before I even think about converting this over to degrees, because I usually don't bother, I know that something divided by 6 is either related to a 30 degree or a 60 degree. That's just something that I have memorized. You guys can think about it like this. Hey, I know that going all the way around from here to here is pi. 5 pi over 6 is really what? I'm taking away a pi over 6 here. If I had one more pi over 6, then I would have 6 pi's over 6, meaning I would be able to go all the way over to pi. So this is 1 pi over 6, this is 2 pi over 6's, 1, 2, 3 pi over 6's, this is 4 pi over 6's, and this is 5 pi over 6's. This would be the 6th pi over 6. That's what I'm trying to say. So when I want to draw this reference triangle, then what I'm thinking actually is that this triangle, and I'm going to blow it up here, this is just a portion of that 180 degrees. And so now I'll mention to you that I know that that happens to be 30 because of the way I drew the picture. Ready? This has got to be 30. This has got to be another 30. And this has to be another 30 in order to make it be a 90. And this has to be a 30, and this has to be a 30, and that has to be 30 in order for it all to add up to 180. So you see that? So that's how you know without even having to convert into from radians into degrees. But I didn't mean to delete all of that. Okay, so here we are again. Let's have our reference triangle. Then we know that this is 30, okay? Which means what? It means outside here, I know this is 2, my short leg is 1, and my long leg is the square root of 3. And if I want to do tangent of 30, I'm supposed to look to the opposite. This is my opposite, and I'm supposed to look at my adjacent, and this is my adjacent. I could spell adjacent. And so I will say then that my SOH CAH TOA, I just want to make sure that I put the opposite on top and the adjacent on bottom. Now, yes, this would, if you rationalize the denominator, you'll get the square root of 3 over 3. But I'm going to stick with 1 over the square root of 3 because I'm allowed to on the AP exam. No stress about rationalizing. But what did I forget? What was the most important part? And I'm sorry, I do tend to forget. Right here in my reference triangle, this should be negative. Because again, this direction on the x-axis is positive, but this direction on the x-axis is negative. So this distance from here to here will be a negative x value. Okay, and by the way, it will be a positive y value, definitely positive y value, because notice I am at a positive height on the y-axis. Okay, so I know my final answer will be -1 over the square root of 3 or negative square root of 3 over 3 if you rationalize it. And then my darling perfectionists, as always, if you wanted to, you could put the square root of 3 here and the 3 there, and you could put the negative at exactly the same spot as that divider line, and it looks best like that. All right, so cosine of -3 pi over 4 is going to go in the opposite direction. Okay, so let me try to think about what direction we went in here. What direction did we go to? So I had my initial side, and it was here, and I ended up over there. And so this is my terminal side. Now, you might be confused. Well, did we really find out the tangent of that angle? Yes, we did. We did that by using the triangle that was kind of cut out to help us figure out the ratio. It's okay because, as I mentioned before, there are 8 different positions for these triangles. But as long as you figure out what's going out inside of that triangle, what triangle it is you're picking, and where you are in that triangle, you're taking care of the plus signs, the minus signs, you're all good to go. So if I want to go -3 pi over 4, I am going to go this direction instead. But how far will I go, and what kind of a triangle will I end up with? Well, this is supposed to be pi, right? So this would be me dividing this section up into 4s. 1, 2, 3, 4. 4 sections. And I'm saying that I'm going to end up with 3 pi over 4 right here as my terminal side. And what does that leave me with? Well, here, that's 1/4 of pi. This is pi over 4, which is the same thing as 45 degrees. And I'm going to do a better job here. I'm actually going to draw my reference triangle right inside. Ready? This is my reference triangle, where this side is congruent to that side. I mean, it's supposed to be. Where this angle is 45 degrees, and that angle over there is 45 degrees, and this angle here is my right triangle. And again, I have this sense, like I already know a bunch of stuff about this. This is going to be -1, right? Negative because I'm going in that direction on the x-axis. This is also going to be -1 because I'm going down on the x-axis. And then for my square root of 2, that would be my hypotenuse. And if I want to do cosine, remember that cosine, so CAH TOA, is going to be adjacent over hypotenuse, which is going to end up being, ready, -1 over the square root of 2, which you can leave just like that. Or if you did rationalize it, you would say this was the square root of 2 over 2 with a negative sign in front because we were going in that direction. By the way, I never did figure out where we were, even in degrees, but just in case you were curious, this is -135 degrees, okay? So for 8, I want to do cosecant, and I want to do 5 pi over 3. So I know from here to here is a pi, so that's 3 over 3. I need to go 2 more sections. So if I'm going to divide it up like this, this is section 1, this is section 2, this is section 3, this is section 4, this is section 5. Do you see how I did that? But you can convert it using your conversion formula if you want to. You would end up at 300 degrees. So this is the same as cosecant of 300 degrees. And by the way, I'm going to end up right all the way over here. And I don't need any of these helper lines. They actually kind of are a little confusing. And what is my terminal side? Tell me. It tells me that I have a 60 degree angle here. Because if that's 300, then in order to get all the way around would be 360. And so I have 60 degrees left. This right here is my 60. Which means this is my 30, which means this is my 2, and this is my 1, and this is my square root of 3. Okay? Now, how do I know that? How do I know? What is it possible that you could accidentally reverse these two things? Hello, highlighter. There is one more theorem that I use because I teach math too. It's always on the top of my head, which is that the short leg is always opposite the smallest angle. So this 30 degrees should always have the smallest number opposite to it. And that smallest number would be 1. And how do I know, by the way, and I hate to say this around, how come students make this mistake? The square root of 3, I mentioned this in the freestyle, is roughly 1.7, okay? It's 1.707 or something like that. So if you put it as the hypotenuse, that's smaller than 2, and you don't want to do that. Okay, so try to always remember that square root of 3. It belongs to a leg. It's always supposed to be a part of a leg. Now, for cosecant then, what is it that I'm looking for? Cosecant, remember, is, where are we? Cosecant all the way up here to the top. Cosecant is going to be r over y, which is, here we go, using that particular formula, r over y. The radius is 2. The radius is 2, and y is this value right here. The up and down value is the square root of 3. And by the way, I'm so sorry, I forgot to mention that it's negative. Because remember, I'm over here on the negative part of the y-axis. I don't have a height up here. That would be the positive. When I come up here, if I had made a triangle up here, this height would be positive. No, I made a triangle down here, which means I have a negative height. Okay? One more thing I'd like to add before I sign off from this portion of the video, I'm going to call this part A, is that we desperately love our calculator because it totally will give us the answers, and it'll give us the exact answers as well. Notice how cosecant, the answer is different than ours. That's because not only does it give you the exact answer, but it also automatically always rationalizes the denominator.